Okay, so the second video that I have here with the dilations is now going to talk about this first page, two problems where we are dilating about a point that is not at the origin, and the last page, the very, very last problem, is going to be a composite transformation in which we involve dilation. So with dilation about a point that's not the origin. With rotations, we talked about 3 steps. We need to move. Step 1 is we need to move the center of dilation to the origin by performing adding and subtracting. Step 2 will be now we go ahead and apply our coordinate notation, in this case, multiply all x's and y's by that scale factor. And then step 3, at like rotations, we need to move that center of dilation back away from the origin by performing the opposite of what we did on step 1. Let's jump straight into it. Dilation, we're going to dilate triangle ABC with the scale factor of 2, meaning k is going to equal 2. And we're going to use the center of dilation at 6, 5. Go ahead and find, I'm going to have the pre-image coordinates pop up real quick. You can copy if you want to. I suggest you go ahead and read them and fill them in. So here are your pre-image coordinates for A, B, and C. So step 1, okay, this right here will be step 1, matching up here, step 1. We're going to take all the x coordinates and subtract 5. We're going to take all the y coordinates and subtract 6, and then y coordinates subtract 5. If you look here, our center of dilation is at positive 6 on x, so we need to do x minus 6, the opposite. The y coordinate is a positive 5, so we need to take all the y coordinates and do the opposite, minus 5. So here, going through very quickly, I suggest you pause and do these calculations on your own. Use a calculator, we can use those negatives. We're going to have a 3 minus 6 is going to give us negative 3. Our y coordinate 2 minus 5 is also a negative 3. Moving to B, I'm going to go column at a time. X coordinate of 4, we're going to subtract 6 at negative 2. Y coordinate 6, subtract 5, positive 1. C, 6 minus 6, 0. Your y coordinate 4 minus 5 gives you a negative 1. Now that we have our new points, we're at the center, the center of dilation is now at the origin, we're going to complete step 2. Remember that k up above was 2, or scale factor, so in our coordinate notation, we're now going to, instead of k times x, k times y, we'll have 2 times x, 2 times y. Guys, take all of these numbers, multiply it by 2. That is it. If it was a negative, it remains a negative. If it was a positive, it remains a positive. So here, with the first coordinate, negative 3, they both start as a negative. They will both end as a negative. And 3 times 2 gives you 6. So we have negative 6, negative 6. Now we have negative 2 times 2, and 1 times 1. Negative 2 is already negative. 2 times 2 gives you 4. Then we have positive 1 times 2. 0 times 2, yep, leaves it as 0. Negative 1 times 2, it remains as a negative and becomes negative 2. Now we need to move back. So take step 3, we need to take step 1, and we need to do the opposite. So instead of x minus 6, we're going to do x plus 6. Instead of y minus 5, we're going to do y plus 5. So again, we're done with everything. We're in column 2, step 2's column right here, and we're going to take these points and we're going to add 6 to the x's, and we're going to add 5 to the y's. So here we have negative 6 plus 6, landing a prime at 0. And we're going to take the y coordinate, negative 6. We're going to add 5, landing at negative 1. B prime, take negative 4, add 6. We end up at positive 2. Positive 2 plus 5, 7. C prime, 0 plus 6, 6. Y is negative 2 plus 5, positive 3. Plot these 3 points, label them with the prime, connect the points, please. We should have this image on our graph now. Same shape, different size. Now what's going to happen is the lines that we talked about, how you can trace through A and A prime, B and B prime, C and C prime, where they all intersect should be your center of dilation. Those lines are about to pop up to see, do we have the correct points, because they should all go through that center of dilation. So here is your center of dilation where they all 3 intersected, and we do have it at positive 6, positive 5, where we were supposed to have it. All right, let's go ahead and take a look at the next one. Again, I will write down the coordinates right here, about to pop up for you. And now we're going to take a look at step one. Step one, we need to find the center of dilation, and we need to look at whether we're going to be adding, subtracting to and from x and y. So here, with our x first, our x is a positive 4, so we need to do an x minus 4. Our y is at a negative 2, so we need to do y plus 2. I'm going to go ahead and fill out this whole first column first. We now look at, for step 2, we're going to be looking at what is our scale factor. Your scale factor is 1/2. We have a scale factor smaller than 1, so our image is going to be smaller than our pre-image. So here, scale factor is 1/2. So now we have 1/2 times x, 1/2 times y. Step 3, we're going to move this center of dilation back away from the origin. So again, step 1 and 3, we need the opposite. Step 1, we did x minus 4. Now we're going to do x plus 4. Y we added 2. Now we're going to subtract 2. So let's go through our steps here. Step 1, we're going to subtract 4 from every x, add 2 to every y. So here, our x6 minus 4 will give us 2. 4 plus 2 gives us 6. For u, negative 4 minus 4 more, it's not 0, it's a negative 8. 2 plus 2 gives us 4. V, we have 2, we're going to subtract the 4, giving us negative 2. Negative 4 plus 2 gives us also a negative 2. Now we take this column, we move forward to step 2, taking these new coordinates, and we're going to apply our scale factor. We're going to take half of these. Remember, these that are negative will stay negative. The ones that are positive will stay positive. So we have half of 2 is 1, half of 6 is 3. They gave us really nice, easy numbers to take half of. Half of negative 8, it will stay negative. It'll be 4. And then half of 4 gives us 2. Looking down here, our x and our y coordinates are the same, so they will remain the same over here. Half of negative 2 is a negative 1 for both of these. Now let's go ahead and move back. Starting with t, our x coordinate, we're going to add 4. Y coordinates, we're going to subtract 2. So x coordinate 1 plus 4 gives us 5. The y coordinate 3 minus 2 gives us 1. With u, going to u prime, negative 4 plus 4 lands us at 0. 2 minus 2, we should know, is 0. So that will end up at the origin. V prime, negative 1 plus 4, positive 3. Y coordinate, negative 1 minus 2 gives us negative 3. Plot the 3 points, label them with the primes, very important. Connect the dots, and we should see the same image, just smaller this time. Not only did I plot my image, but I went ahead and drew in the lines to determine, is my center of dilation in the correct spot, and we find out that it is. All right, so our last problem here. We're going to go ahead and do composition. Our original pre-image is already on there for us. So we are going to first reflect across the y-axis. So first things first, take a look at that. Reflect across y-axis. Okay, so this step 1 right here, our first one, we need to apply our y-axis coordinate notation. And we know with our y-axis reflection, the opposite coordinate changes to the opposite sign. And now we're going to take a look at, after we get the new points, our single prime, we're going to dilate with a scale factor of 1/2. The center is at the origin. So all we have to do is take our prime points, multiply by the scale factor, and we have our new points. There is nothing like what we just did on the previous page. So here this would be 1/2 times x, 1/2 times y. So that center column, we just take half of those numbers. So let's go ahead and take a look real quick. Let's look at primes and then plot prime. J, we're going to, we have negative 2, 1. All we're doing is changing the sign of the x. So J prime, we change the x to a positive 2, and we have a positive, the y stays as positive 1. K, for K prime, we're going to change x's coordinate from a -2 to a +2, and y coordinate stays the same. L prime, -4 on the x, changes signs to a +4, and we end up with, leave our y the same at 6. M prime, change x's coordinate, it's a negative, change it to a positive, leave y alone. Please go to your graph, plot all 4 of these, label them with a single prime, and connect the points. And this is what we should be looking at. I didn't use the straight edge, it's not perfect, but it's okay. So now we're going to go ahead and take all of these numbers from J, K, L, and M, and all we're doing is taking half. If it's negative, keep it as negative. So here, J prime, half of 2 is 1, half of 1 is 0.5, or you can put it as half. I like to put it as a decimal because I have to read it on the graph. K prime, okay, K prime is going to go K double prime, half of 2 is 1, half of 6 is 3. L double prime, half of 4 is 2, half of 6 is 3. And M double prime, half of 4 is 2, half of 1 is at 0.5. So we're going to go ahead and graph these. I'm going to go ahead and graph all of them on here with you so you can see this 0.5. J prime is at +1, +1/2. So I'm not going to go all the way up. I'm only going to go halfway up. My J right here is in the way. I'm going to go ahead and move that. I go over +1 up halfway there. And here we have J double prime. K double prime is going to be a +1, +3. L double prime is at +2, +3. And M double prime will be at +2, +1/2. So right here, kind of overlapping my little letters here. Here's M double prime. We connect those points. You can shade that in to show this is our final final image here.